Hello, am I audible?
Yes, sir. Yes, sir.
Okay, okay. Hello. So before we start, if you have any doubt from week 2 or week 1, please tell. We'll start in 1 or 2 minutes. So good afternoon, everyone. So this is Rahuldev Ghorai, and today it will be your third week tutorial for the engineering mathematics 2. Will as you know, the today's topic is mainly on some complex analysis things only. So complex analysis few concept in complex analysis. So you know few things and few you will know while doing the question, while solving the question. Okay. So we'll start with some basic questions like if you have a complex number z, how do you find its conjugate? Okay. So it's simply given by if you have AB and what is A plus BI if they write in geometrical interpretation. Okay, let me just save it. Okay, 1 minute. Okay, so now it's okay. Yes. So you have a complex number. Let's say 1 plus 2 times I. This is nothing but, I mean, we can visualize in R2 plane like this. If it's a, this is 1 and this is 2, I mean, let's say 1, 2, right? You can, I mean, geometrically, this complex number, complex plane can be interpreted as R2. And when you say conjugate, so you have, let's say, let's say 2 1 point here, then that is corresponding to 2 plus I, and the complex conjugate then it will be, if it is A plus BI, then complex conjugate will be A minus BI. So complex conjugate of 2 plus I is 2 minus I, which corresponds to 2 minus 1. So when you have a point, you get the complex conjugate will be a reflection along the reflection along x-axis, right? So that is nothing but a complex conjugate, a conjugate of a complex number. So conjugate of a complex number is nothing but the reflection through x-axis. Okay. So, but when you have complex number, let's say like say given in the first question, 1 plus I. When you have A plus IB types, then you just write it, or A plus BI, that you can write A minus IB. But what about if this is like 1 plus I times 2 plus I over 3 plus I? So how we do that? So first we have to change it to like A plus IB form and then just put minus, right? It's not it. So you know the complex number a little bit theories, right? Or like,
Yes, sir.
okay, Sandeep. So what can you just do it, or like let me do first, then you do the second maybe.
Sir, sir,
Yes.
first take conjugate of numerator and denominator, sir.
Conjugate of numerator or denominator, then will that be that I have to check. Now let us check now itself. Okay, you are asking that question, right? Or is it true?
Sir, conjugate of Z1 upon Z2 is equal to conjugate of Z1 upon conjugate of Z2. Is it true, no?
That's what I am also asking. I don't know whether it will be true. Whether it is true, that's exactly you are asking, right?
Yes, sir.
That I can prove also whether it will be. But let's see for at least this example whether it will. happen. So what you do, you try to do by that z1 bar over z2 bar. Okay, you tell me the result. I will do by z1 over z2 bar, then we will know at least this case. If it is not happening, then we can say that it won't happen, right?
Okay.
Yeah. So if you are not doing also, I will also do, that is not a problem. So let's do it. 1 plus I over 1 plus I times 2 plus I will be 2 plus I plus 2I plus I square, right? What is I square? Is minus 1, so it will be 1 plus 3I. And you have now 1 plus 3I over 3 plus I. So what we will make? 1 plus 3I times 1 minus not 1 minus 3I, 1 plus 3I times, we want to make the this 3 plus I times 3 minus I, then 3 minus I, right? That will make you 3 plus 9I minus 3I square plus 9 sorry 3 plus 9I minus I, right? Minus 3I square minus I over 9 minus I square, which will be, this will be 10, I square will be minus 1, right? So it will be 6 plus 8I, 3 over 5 plus 4 over 5I. Okay, so but so I wrote this as 4 plus 3I. So this one will be 4, sorry, 3 over 5, 3 over 5 plus 4 over 5I. So complex conjugate of this will be, then the answer will be 3 over 5 minus 4 over 5 times I, right? So but will you get the same thing when you do this z1 over z2 bar? Z1 bar over Z2 bar. Let's do it for this one even. What is Z1 bar? Z1 bar will be, sorry,
1 minus I multiplied by 2 minus I.
1 minus 3I over
1
3.
minus I multiplied by 2 minus I.
Okay, yeah, that will be 1 minus 3I only, right?
Yes, sir.
No, right?
Yes, sir. 1 minus 3I.
Exactly. So that's what I first did. This 1 plus I times 2 plus I, that is 1 plus 3I. That's why. Okay, 1 minus 3I over you
3
take 3.
minus I.
Okay, now multiply. It seems it will be same. So 1 minus 3I times 3 plus I over, it was 3 minus I, right? Times 3 plus I. So which will be 10, and then 3 plus I minus 9I minus 3I square. So 6 minus 8I over 10. Oh, it eventually comes out to be same. So maybe one can prove that these conjugates are same. Okay. Anyway, whatever way you get, that will be same answer, right? So what you can do, you can, so most probably it will be true. Okay. I can't recall, but that is very easy to show that. You just take Z1 equal to A1 plus IB1 and Z2 equal to A2 plus IB2. Can show that it is maybe equal. You have to check that. Okay. Eric, you have Z1 and F Z2. So you know Z1 bar over Z2 bar. So that will be a1 plus a1 minus ib1 by this a2 minus ib2, and then again you do the same thing, a2 minus ib2 times a2 plus ib2. All these things you do here also, you multiply, and again you know this z1 over z2, that part, that also will be equal to like same. Or also one can always do like this, z1 equal to r1 e to the power I theta 1, also you can write like this, right? And z2 is r2 e to the power I theta 2. For any two complex number, one can write this polar transformation. Now what is z1 bar over z2 bar? That will be r1 e to the power minus I theta 1, and this will be r2 e to the power minus I theta 2, right? So that will be r1 over r2 times, any question, r1 over r2 times e to the power I theta 2 minus theta 1, right? And when you take z1 plus z1 over z2, that whole bar, that will be r1 over r2 e to the power I theta 1 minus theta 2 whole bar. What is that? r1 over r2 times e to the power minus of I theta 1 minus theta 2, that is I times theta 2 minus theta 1. Yeah, so that is same actually. Okay, the conjugate, like whatever you were asking, that is actually equal. So you can write as z1 over z2 whole bar is z1 bar over z2 bar. So you can do it any way. Two way you can do. Let's first you make it a plus ib type of form, then you just change it, or you just first actually you change it and then you find out what is a plus ib, right? Is it okay, Sandeep?
Yes, sir.
You understand, right? This one also, last part.
Yes, sir.
Yes.
Yes, sir. Understood.
Okay, okay. So then you will see the answer. This is the first part I did, which is not written here. The answer, otherwise answer is for second part is here. So can you do this?
Two times e to the power pi I by 3.
2 times e to the power
Pi I by 3.
pi I by 3. Yeah, that should be okay, because what you do are cos theta plus I r sin theta, right? You can write any z as like this, and then you make r cos theta equal to square root 3, r sin theta is equal to 1. Then taking this 1 and 2, 1 square plus 2 square will give you r square equal to 4. That's will be r equal to 2, as r is positive. And theta you can write then, theta will be cos inverse square root of 2, which is pi by 6. Other values are there also, but one of the value will be pi by 6, and that's how we can write. No, pi by 3, right? Not pi by 6. It should be pi by 3. So 2 times e to the power pi I over 3. I think answer is also given. Oh,
Sir, it is pi by 6, sir.
pi by 6.
Yes, sir. Sir, cos 60 degrees is 1 by 2, sir.
Okay, okay. It is sine, not sine. Okay, okay, pi by 6. So I was written first Okay, then yeah. 5 by 6. 5 by 6. Not 5 by 3. Okay. So that is the answer. Then it is not a big one. So then it comes to this limit of the complex function provided inside into their continuity and differentiability. I mean, we not just need to find whether it is differentiable. Sorry, the limit exists.
Minus times 1 plus 2i upon 1 plus 3i.
Sorry, minus.
Minus minus 1 plus 2i divided by 1 plus 3i.
Okay, so how you do it? Just you put 1 plus I value in this in this limit in this function.
Yes, sir.
Yeah, because the denominator it won't be 0, right? Numerator it won't be 0. So z square plus I plus 1 at I plus 1 will be I plus 1 whole square plus I plus 1. So it won't be 0. So you just put the value, whatever value you get, that will be the thing. So it's 2I plus 1 plus I square root minus 1 plus I. Yeah. So it will be 3I plus 1, the denominator, and the other one you have to again just calculate it. I have shown it here. So you can substitute, yeah, you have to substitute like this, and then what you told this 1.
Yeah, this is correct, sir.
Yeah, that's correct.
I got this answer.
Okay, great then. So it is correct, whatever you wrote. Yeah. So next is this one. This one, yeah, interesting. You do it. You want to do it, right? Or I will do. I have no problem. I can do, but seems you feel it seems you are interesting to do. So you do it first, and then after that I will do. Okay.
Yes, sir.
Okay.
So p less than 0.
P less than 0.
Yes, sir.
P less than 0. I mean, No, I don't think it told me. What you did tell me.
Sir,
So
for continuity, the limit should be equal to the value of the
true,
function at
true.
that point.
Yes, yes. Limit z tends to, then you have to do z tends to
Minus I.
minus I. Z square plus 1 over z plus I to the power p has to be equal to
Equal to 0.
0,
0.
right?
Yes, sir.
Yeah, has to be. So has to be for continuity. Continuity, right? So now what you did, let's evaluate what is this, because when you
Sir,
evaluate you will get plus I to the power p.
sir, in order to get this limit equal to 0, if denominator comes up, then it will be, sir, 0. So if p less than 0,
P less than 0 might work, but there has to be there you can get better P value. So value of P might be better also, right? You just trivially put P is less than 0, then Z plus I will be above of this Z square plus 1, right?
yes, sir.
With Z square plus 1. But you can do also like this. See, Z minus Z tends to minus I. Z square plus 1 can be written as Z plus I times Z minus I, right?
Yes, sir.
Then Z plus I to the power P. That will be equal to limit as z tends to minus I, but z is not exactly minus I, so that one can evaluate z plus I times z plus, sorry, not z plus I, z minus I times, what I mean, what is z plus I, yes, z minus I times z plus
Plus
I
I,
to the power 1
power
minus,
1 minus p.
right?
Yes, sir.
Now this will be equal to minus 2I times 0 if 1 minus p is greater than 0,
Hmm.
right? 1 minus p is anything which is greater than 0, not equal to, right? If equal to 0, then z minus I will be only minus 2I and this one will be 1. So this is possible only if 1 minus p. See, if 1 minus p is greater than 0, then limit of z plus I, sorry, some limit of z tends to minus I, z plus I to the power 1 minus p only 0. Only if, not like just like your p is equal to 0, and only if this happens then it will be 0, right? And that implies this equal to 0 if p is less than 1. See, what we initially realized that if p is less than 0, that will work. Of course, that will work. But even with p less than 1, when p is less than 1, p is also less than 0.
Yes,
Right?
sir.
So, even p is less
But
than
the
1,
values between 0 and 1 will be left for
will
p
be.
less than 0.
Yeah, will be late. But so that's why this is the more you got best one, right? Better result than
Yes,
this,
sir.
right?
Better, better.
Yeah. So p is less than 1, even it will work. So that's why this mathematical analysis is important, right? We can see by just a simple observation, but mathematical analysis gives more precise value of p, right?
Sir, in
Okay.
case of complex valued functions,
Yes.
then we need to, sir, change them in x y, sir, in terms
Same.
of x y.
Limited.
Yes, sir.
What you are asking, please tell. Uh,
Sir, sir, I
yes.
want to ask that if the things get complicated, then we have to change z in terms of x y, sir,
Ha. If we
for
if
limit and
we,
yes, sir.
exactly. Then it will be same type of analysis like in a, right? So you just put x plus I y wherever it is. It will be little bit complicated, but things will be okay for continuity. For differentiability, it will be little bit different. You
Yes,
will
sir.
see if you
Yes, sir.
read
Yes,
the.
sir.
Yes, yes. Okay, that this is okay, right? Then the solution will be this will be 0. So what were the values? So values are p is less than 1, strictly less than 1. I am also planning to make a video on like some small video made on here. So one can prove minus 1 equal to 1 using some very weird analysis, which they use, right? Something like this, right? Minus 1. I don't know how they do, but I'll see that part I have seen. So that is not exactly the mathematically it is true. You can do that using uh, using the complex analysis square root thing. So what they do is 1, I think, is will be equal to 1 times 1, and then square root of minus 1 times minus 1, all these things they do, and then you can write again this is equal to minus 1, that type of things, right? So why it is not true that we can verify it using complex analysis, because square root of
How
minus,
this is, sir, minus 1?
sorry, yeah, I mean,
How can
just,
you write this?
yeah, you cannot write. I
Yes, sir.
can, that's it. But people do the many where like some stupid analysis people do. That's what I need to make a small video on this, which will be in maybe YouTube video. So that, but the thing is, yeah, I mean, what they write is minus 1 whole square root of it, that is equal to minus 1.
No, sir. Yes, sir. I
That
times I, sir. Basically, they write I times I.
exactly, or I times I, that is
Yes, sir.
minus 1.
Yes, sir.
But that won't be the case. So that is nothing but I, means square root of I is defined in such a way it is square root of minus 1.
Yes,
So
sir.
then I square is equal to minus 1. But
Yes,
when
sir.
you write a square root of minus 1, that is defined in a complex number way, it is not in a real number sense. So those things matter. So yeah, so that is a different thing anyway.
So you cannot write, sir, root minus 1 is equal to I.
Sorry.
Sir, you can, what you want to say that under root minus 1 cannot be written as I.
No, no, I'm telling it can be written. It is denoting by, we are denoting something I, that is nothing but square root of minus 1. So I is a notation which is for square root of minus 1. I'm not telling it it cannot be.
So, sir, root minus 1 times minus 1 can be written as root minus 1 times root minus 1. Can you write this, sir?
That I cannot write. That's the thing. So
So where is the problem, sir?
that in defining square root of minus 1 is the problem. Defining square root of minus 1. How you define square root of minus 1 first of all? That is the question. That's why I'm telling. That's why I'm telling.
Sir, if sir, ab to the power m, sir, is equal to a to the power m into b to the power m, sir. So in this
A
case,
to the
thus
power a to the power n times b to the power n equal to
is
ab
equal
to
to
the power n.
whole
That's
power.
true.
Yes.
Yeah, that is
So
for any real numbers, right?
yeah, any real number. So here, sir, minus 1 times minus 1 to the whole power 1 by 2, sir. So minus 1 to the power 1 by 2 times minus 1 to the power 1 by 2.
No, first of all, square root. How you define square root for a positive number usually, right?
Yes, sir.
So square root of minus 1, how you define first? It is not like minus 1 to the power just half in real sense. That's what I must. That is what I'm telling, trying to say. What is square root of minus 1? It is,
Sir,
you don't
I.
you first you cannot define square root of some negative number. Square root of always we define positive number, right? X is positive. When
So,
square root of minus 1 it comes, how you define that, you say first.
sir, I, sir.
I is a notation. I is a notation for this. I am just denoting it by minus. That is by minus I. Sorry, I. That is nothing but minus 1 to the power square root minus 1 to the power half.
Okay, sir.
Yeah. So there exactly If you understand that, then only you will understand why
Actually, sir, I denotes the points are 0, comma 1, sir.
I is 0 comma 1.
Yes,
Yes,
sir.
yes. Then you
I
define
yes, sir.
what is z to the power half, how people define in complex number. Then you will understand minus 1 to the power minus 1 square root or minus 1, what is that?
Yes,
I'll
sir.
tell you. But otherwise, you can check. I just what I planned that I will make, maybe because in this class it won't be easy to do. So I will do it in a small separate video in my this YouTube channel. Okay, you can
Okay,
check
sir.
that. But yeah, you are here. I can little bit say. So the thing is, when we define square root of z, okay, so
Yes, sir.
I mean z square equal to w, it will have two solution, like plus minus square root of modulus of w times e to the power I times argument w over 2. If z square equal to w, will have z will be equal to plus minus square root of like this, right? So now
Hmm.
when you have instead of uh, instead of w, so what we want to make x square, or sorry,
Minus 1.
z square equal to minus 1, right? So what
Yes,
will
sir.
be then if w equal to minus 1? When w equal to minus 1, your z is nothing but that square root of minus I, that type, minus 1 type, right? That's then the
Yes, sir.
solution. So what will be then minus 1? Minus 1 to the power this one, it will be nothing but square root of that minus 1 mod n times e to the power minus I times whatever the argument of w over 2, that type of things it will be, right? It's not the exact that minus 1 to the, that definition you have to use here. It's not the minus 1 in the usual sense. When minus 1 times square root of minus 1, all these things you cannot do because these are not
Why?
real sense, in the real sense you have to use this definition and then do it, right?
Yes, sir.
Yeah, then you will not get that thing, same thing.
Okay, sir.
So then in that case, w square root of w is nothing but in the complex number modulus of w times e to the power I argument argument w
W.
over 2. That definition says it is this. It is not just square root of minus 1 is in that other sense. So square root of when w times square root of w, any complex two numbers, that will be your w square. Square root of
Yes.
w square. I mean
W,
w
W.
plus modulus of w.
Okay, sir.
No, no, sorry. That is a mistake. Sorry, that is the mistake. So this won't be like this. So when you
W,
take,
sir.
so when you take this, so it won't be w square. It won't be w square. That is the mistake we are doing. So when you take minus 1 square root and minus 1 square root, so it should not be square root of minus 1 whole square. So that point we are making mistake. That's what I will make a small video and I will upload it. Okay.
Okay, sir.
That's the thing. Okay. Yeah, but this is correct. So p is less than 1 we have done, and then fifth question do it. This is also very interesting question, right? But very easy question.
The del upon sir, del Z bar, sir. Del Z bar, sir, is not
Oh, great.
0.
Yes, yes. Del f over del z bar. What has to happen?
Minus 1, sir. It must be, sir, 0 if it is differentiable, sir.
But if it is 0, can you say it is differentiable?
No, sir.
Del f del z bar is equal to 0. Then f, let's say at a point a plus ib.
Sir, this is necessary condition for differentiability, sir. At
Good,
some
good,
point.
good, good. Then if I was asking, I knew this. If is differentiable. So no answer is no. So this is actually the necessary condition, which means that if del f del z bar at AB is not equal to 0, then f is not differentiable, right, at AB. Am I correct? Whatever you are telling that, right?
Yes, sir. Yes, sir.
Yes. Okay. So then what we have in this case here, del f del z bar is equal to negative of 1 in like for all z. So del f del z bar at z equal to any point for any z belongs to C complex number is equal to minus 1, which is not equal to 0. So with this function f is nowhere differentiable. We use this language, nowhere differentiable. Okay, good. So you have gone through the lecture notes, all these the, or you are from maths background?
Yes, sir.
You are from maths background.
Yes, sir.
Okay, okay, good. Then this will be little easier for you. I thought engineering people will come. That's why I did not take that much difficult questions. But these are decent questions also, I mean, for both of you people. I mean, first few were not difficult, but these are, I mean, all the, it's not difficult, but these are interesting questions. This also, both of you should know. I mean, they should know also, we should know also. Right. So, yeah, now it comes to now CR equation, right? So,
Yes, sir.
find the correct function Vxy such that complex function is analytic, where Uxy is e to the power x cos y plus y square. Try.
Sir,
Sorry?
no, sir. Nothing.
Yes.
Sir, I think, sir, there is some mistake in your, sir, option, sir.
Why?
Sir, CR equations must be, sir, satisfied. So UX is equal to VY, sir.
Yes.
But
Ux. Ux
sorry,
should be
UX is V
Vy.
to the power X cos Y. Yes, sir. And UY is equal to minus VX.
So Ux is e to the
UY,
power
sir, yes,
Ux equal to e to the power cos
cos
y.
Y.
And that case By should be
E to the power X cos Y. But all options are not satisfying. So this.
e to the power x cos y. Why not? B to By, the DUS option can be also, right? D option By if you take it to the power x cos y.
Sir, there is a Y square, na, sir. So plus 2Y be there, sir.
Oh, sorry. By
Sir,
square.
every, sir, yes, sir.
I understand. I'll make sure that what is the.
I think, sir, there must be, sir, X square, sir. I think plus X square.
Yeah, most probably. Let me check it. Then we'll see. You try to find out V, okay?
Okay, sir. Okay, sir.
Without looking at the options, I'll check. I'll correct the option.
Okay, sir.
Now I'll check. So I can show that this.
Sir, 5x,
Sorry.
nothing.
Some mistake is there, right, in the
Yes, sir.
question.
Yes, sir. Minus 2xy, sir.
So which cannot happen. I think it should be 2x.
Sir, you must be, sir, harmonic, na, sir.
Exactly. That first also
I
it.
think, yes, I think you is not harmonic, sir.
Okay, okay. Because this question should be. We have to just verify. You have to leave this question away. So this was some from somewhere I got, but it is not a harmonic function. Yes. So if you take uxx, there will be uxx will be e to the power x cos y,
Cos y. Yes, sir.
and
Only
uy
y
will be e to the power x sin y
plus 2. Sir,
2y.
2 is, sir, 2 is there, sir.
Uyy will be
Not equal to 0.
yes, 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 e to the power x. So this thing should be
The plus 2 will be there, sir.
yeah, yeah, I mean, I did not write it, but yeah, that is cos y plus 2. I understood that it won't be, that's why I'm not writing. The thing is how to make it just leave
Harmonic.
the y square, but then options will be different.
Sir, only take, sir, e to the power x cos y, sir.
Then it will be, but it will be then very easy. Either it only take u to the power x cos y, then it is okay. Otherwise, some y square times x or some such thing I was thinking. Y square plus x square, right? That will be most probably.
Y square plus x square.
Y square minus x square, sorry, minus x
Ah,
square.
yes, sir.
So if you do that, what will be the answer? Let's say I take y square minus x square. Okay, so my things, all the things will be okay here. I will be writing y square minus x square. Then ux will be minus 2x and uy will be same. Then
Sir, y square is there, sir, again, sir.
vx. Wait. Vy will be minus 2xy. And if vx is like this, so it won't be. I mean, you have to make some other, but it should happen because when you have okay, maybe it's a different one. Okay, it's a necessary condition, right? This harmonic function. It should be harmonic, but it may not. If it's you start with a harmonic function, will that have the this? You can make the function analytic. That is one question.
I think, sir, this is if and only if condition, sir. I think.
Now, then why you are not getting here? So that's a big question now, right? So we start with ux is equal to uxy is equal to e to the power x cos y plus y square minus x square. So uxx plus uyy is 0, right? We are not making any issue there, right? So ux will be e to the power x cos y minus 2x. Uxx will be e to the power x cos y minus 2. So what is uy? Uy is e to the power minus e to the power x sin y plus 2y. So uyy will be minus e to the power x cos y plus 2, right? So uxx plus uyy is 0. So this is harmonic function. So when you have a harmonic function, then you should get a harmonic conjugate. So you start with ux, which is to the x minus 2x, uy is to the minus x sin y plus 2y. Then if you have a CR equation, by is like by will be ux, that is e to the x cos y minus 2x. So then b will be like this, minus 2xy. So where I am making mistake, then e to the power bx. Okay, so then here, from here what you can say, b is nothing but e to the power x, e to the power x sin y minus 2xy plus 5y. Some psi y. So phi x and psi y has to be same. Okay, okay, understand. So phi x equal to has to be psi y. So then that implies this should be a constant function. It cannot happen that phi x, which is a function depends on x, and psi y is a function depend on y, they are equal. So then it has to happen that that is equal to a constant function. So that implies your v has to be e to the power x sin y plus phi x, sorry, phi x is a constant, plus, not plus, minus 2xy plus constant, that is your phi.
Sir, all
Yes.
harmonic functions need not be sir analytic, sir. You are right, sir.
Yeah, that is right. But in this case, we can do this. See? We can do like this. You understand what I am trying to write here? And then your answer will be, I think one of the answer also is correct. Your x sin y minus 2xy plus c. See, this one
Yes,
is
sir.
correct. Option C will be correct. It is x sin y minus 2xy plus c. So you take like this, y square minus x square. And then you just use CR equation, try to make v from both, and you will see v will be equal to, and both the v has to be equal, and they are same function we are trying to find out, but we are only having difference in phi x and psi y. We suppose that phi is, here is phi is any arbitrary arbitrary function which depends only on x, and here you have psi only depends on y. So that if they are equal, then it only possible is they are constant. So they does not depend on x or y, so they will be constant. So that is given by this some constant. Okay. Sorry.
Yes, sir.
Okay. So if so, we will move to the seventh question. I think this is the answer given, but it's not. Maybe
Sir, what he has taken, so what you have taken in this solution? You.
sorry, sorry.
What is you, sir? Your solution, sir.
Which one here?
Sir, in your solution, sir.
Yes. Okay, okay, okay. Not my solution. The solution also was in that assignment. So I just took that and I just wrote it
So
long time back.
he has taken sir the same you.
Yeah, that's still. we got the same. Let's see here. E to the power x cos y, x sin y, all these things. We also got a whole everything, right? Like this, and we get here. Okay, 5 prime x equal to 2y. So 5 is the final function of x, so it must be with respect to y, meaning the correct function must be both x and y. So 5 they take it like this, that's why. So in that case, this 5 prime will be, so they treat phi as minus 2xy plus c, so that 5 prime x will be, but that is not a correct way to do, okay. Right, I mean it's a, I thought it is a correct way to reach. It should not be a correct way because 5 here, assuming it is a constant function, is a function which is with respect to only x. It's constant with respect to y.
The 5x is not representing the partial derivative with respect to x, sir.
Exactly. It's
How can it take sir y as constant? Treat y as constant, sir.
sorry. Phi. I
Sir,
mean,
sir,
phi
we
is a
had
function. I am assuming phi is a function which depends on x
yes, sir.
only.
Sir,
That's
solely
all.
depends upon x, sir.
It's only takes upon x. Exactly. So that's why I am telling it is not the correct way.
Yes, sir. Sir,
Right.
sir, in this, if we sir check sir the CR equations, then CR equations will not be sir satisfied, sir.
Yes. Your equation will not be satisfied in that case if you take.
Yes,
But
sir.
if you take b is like this, then CR equation will not satisfy, right?
Yes, sir. Minus is there, sir.
Yeah, exactly. So that's why it is not this solution is not correct, but this solution is correct, right? This
Yes,
solution
sir.
with respect to minus x square, and this one I will just cut it, and that will be uh, posted in that uh, mm, group. Your drive, Google Drive. Okay.
Yes. Sir, option A should be correct.
Resolve.
Option A,
What is sine hyperbolic x?
e to the power x minus e to the power minus x by 2.
2 or 2i? What is correct?
No, no, sir, 2. Only 2.
Sure.
So that is sin x, sir.
No, that is not sin x with
Sin x
ix.
to the power ix minus e to the power minus x by 2i.
Yeah, it should be ix then also.
Yes.
So when you take derivative of sine hyperbolic x, that will be cos
Cos
x.
i by.
And the
Yes.
other way also. I mean, no sign negative and all these things are not there, right?
Yes, sir.
So then ux in this case will be
Hmm.
cos hyperbolic x times cos y.
Hmm.
And uy will be sine hyperbolic x times minus sine y. So what will be our Vx? Sorry, Vy is negative of, sorry, Vy is equal to cos hyperbolic x cos y. This means it will be cos hyperbolic sine hyperbolic x cos y. This one plus some other function will be there, right? So that function will be a constant because uy is minus of vx, that will be also same cos hyperbolic x cos y. So the answer will be the first one, right? Which one you said?
Sir, option A, sir.
Option A, yeah. Then is correct. I am also getting option A. We'll see. Yeah, that's one. So
He discarded the sir options, sir. Not solved, sir. Actually, sir.
sorry,
Sir, I have not solved, sir. Actually, sir. Not find, sir. V.
you
Only,
found
sir.
B.
Six. Yes, sir. I discarded the option, sir.
So which one you got? First option A, right?
Option A, sir.
Yes, yes. So you
By
discarded.
CR equation, sir.
Yeah, good, good, good. That is also one way to do. Yes, yes. But when you have big expression like V is like we have to derivative will be difficult. I mean, difficult means very lengthy. Then it will take time, right? So then
Yes,
this
sir.
way will be easy. No need to check all the thing. You just get answer of the question, right?
Sir,
Yeah.
harmonic conjugate is, sir, sorry, unique, sir. Up to, sir, some constant, sir.
Up to constant. Yes, up to constant.
Yes.
Okay. So this one.
Sir, sir, in ML inequality, L is length of the curve and M is the upper bound of these
Of the
integrals.
function. Of the function. Good, good. Yeah,
Yes,
yeah. Exactly, exactly. You are
integrand,
correct.
sir. Yes.
You are correct. Do, do, do. Please do.
5/2.
Okay, we'll check. We have to check it whether pi by 2. We'll see it. How you got that?
Length of the curve is 2 pi.
Yeah, length will be 2 pi. That is true.
Sir, I am having problems, sir, with the upper bound of the function 1 by, sir. Sir, denominator, sir, will be, sir, should be, sir, smaller than 1 by z square plus 5 will be greater, sir. So,
Yeah, yeah.
sir, sir, took, sir, z is equal to 0, comma minus 1, sir. Sir,
But why?
sir,
Hmm.
I took, sir, z is equal to I, sir.
Why?
Sir, then, sir, minus 1 will be there and, sir, 1 by 4.
Yeah, but why not z equal to 1?
1 will be, sir, this will be lesser than, sir, 1 by 4.
But yeah, how do you know that this at z equal to I will be, it will be maximum, and you just assume this it's 1 by 4 will be the maximum of this one, this function. You have to prove that, right?
Hmm.
Yeah. You cannot just assume and do it. You cannot do that.
So we have to check on the curve, na, sir, maximum of the function, sir.
That is true. That is true. Yeah.
Sir, no idea, sir.
Okay, so what we do is, I mean, fz means 1 over modulus of, you can think also z square plus 5, right? I mean, modulus of fz, you have to find out whether that is like how to make that is less than equal to something, right? So, okay, 1 minute. Yeah, we have place also. When you have this 5 plus z square, this modulus, that will be less than equal to 5 minus z square, right?
Yes, sir. Yes, sir.
So which will be always greater than equal to
There
4.
should be also, sir, modulus, na? One modulus outside, sir. Modulus of 5 minus modulus z square.
Sorry.
Sir, modulus of 5 plus z square is greater than or equal to modulus of 5 minus modulus of z square.
But if 5 minus z, yeah, that is equal to 5 minus mod 0 whole square, because z is equal to e to the power it is there, right? Z is equal to e to the power it, right?
Yes, sir.
So modulus of z will be
1.
1. So yeah,
It is
that is,
always positive.
so which is equal to 5 minus 5 is bigger, so that's why I wrote modulus, instead of modulus is 5 minus mod z square. So that is greater than equal to 4. So then you can write that 5 plus z square modulus is less than equal to 1 over 4. Your answer was matching with this one. I mean, it was kind of same,
5
but
by
it's
2.
not the, yeah, it's not the correct way to do, right? Because you do not know whether 1 by 4 is, but in this way you can say that 1 by 4, at least 1 by 4 should be there.
Sir, by maximum modulus principle, sir, the sir maximum is always attained on the sir boundary, sir. From that, I did it, sir.
Maximum modulus principle. Okay. Maximum modulus principle of z, okay, z square plus 5. You have z square plus 5, right? So minus 2y. Okay, this will be analytic in this region.
Yes,
Minus I by 2, the whole circle. So then all these things also you have to, you know, that's good, that you have to say. Then you use the maximum modulus principle, then might be it is okay. But maximum, wait, maximum modulus principle says that it attains on the boundary, the maximum, right? So this
yes.
is 1 0, which is also on the boundary. Why you took then 0 I?
This is sir also on the sir boundary, sir.
Yeah, but maximum.
Maximum in the sense, sir, sir, maximum, maximum is sir minimum, maximum or minimum, sir, both.
Yeah, maximum and minimum both. That then it
Both
will
are
happen.
attained.
So
Yes,
it will be minus 1 0, and this 0 minus I. So in this 2 point or some other point might be there. There it, but why this maximum on 0 I? I mean, some, why not some other function where it will be, or some other point where it can be maximum also, right? Why 0 I? Why you think that at 0 I only it will be maximum? You understand my question?
yes, sir.
Yes.
Sir,
So
because sir, there at other points, sir, there is a point of sir, x comma y, sir. X will be there, y will be there, sir. Then we'll
yeah.
be
So
getting
what is the problem? X will be there. While there, what is the problem?
sir, we get sir as a denominator bigger, sir. Then the whole thing will be sir
No.
smaller,
Yeah,
sir.
that is the exact reason here you are writing in mathematical way. That's the mathematics you are writing here. So you have to write in mathematics, in mathematical language. You cannot just say that. So you have to write in a mathematical language.
This is sir, this is correct.
Which one?
Yours, sir.
Yeah, 5 minus z square, and that is how we are getting 5 plus z square is greater than equal to 4, and maximum will be always, will be also at 0 I or 0 minus I. Those are all are true, but you have to prove like this. So prove,
Yes.
because this is always greater than equal to 1 by 4, so it will be less than 1 by 4 at 0 I or 0 plus minus I. It will attain the maximum also. Those are correct after doing this. Okay.
Sir, can we sir find this point of maximum minima by changing it in sir xy and then sir compute sir partial derivative with respect to x and y, then put it equal to 0 and find the value of x and y, sir.
Yeah, that should work. That should work because it is like you are doing
Integral variables.
per set. But yeah, maximum modulus principle is, so it is like one, what you are telling, x plus iy whole square plus 1, you take f of xy like this, right? You can do, I mean, then fx fy,
5, sir. X plus I y square plus 5, sir. There is 5 in place of 1.
sorry,
Sir,
plus
f
5
of
5 plus 5,
yes,
yeah, whatever is there, whatever is there. So and z square means x plus I whole square, and fx fy,
yeah, this
and
is
then,
correct.
but it will be very
Lengthy.
lengthy, very
Yeah,
lengthy,
yeah.
because you have to x plus iy is below, so you do not know about
Sir,
that
it
thing.
will be sir 0, sir, na? When we'll put it to equal to 0, then the denominator will goes out.
No, but that is the thing. So x plus iy whole square, it can happen that y is equal to square root of 5, x equal to 0, then your this thing will be 0 denominator, so you cannot say that this is non-zero number. You understand? So you have to make it non-zero number in the denominator.
Yes,
If fx equal to something you get, let's say a over this quantity, right? Over this one. So this one you
yes,
put here, but that is equal to 0. If it happening, then a is equal to 0. You cannot say that because this one can blow up. This one can be 0 because for x equal to this and y equal to this, this 0. When you have x square plus 5 in where x is real number, then it will be always strictly greater than 0. Then you can
mm,
write that. Yeah, but when you have 1 over z square plus 5, this z square plus 5 can be equal to 0 also.
yes, sir.
Yeah, so that is the difference here. And it can happen that it is less than 0 also, right? Because you take y is equal to square root of 6 and
Mm,
x equal to 0, then it will be minus 6 plus 5, so it will be minus 1, so it will be less than 0. It can be also. So z square plus 5, you cannot say anything about that, although you can talk about x square plus 5, which is positive always. So that's why you have to care about those things also. You can think about those things also, right?
yes,
You understand what I am saying?
yes, sir, yes.
Yes, yes. So then it is pi by 2. Answer is correct. Your answer is correct. Yeah.
So zero,
Why?
zero.
Why? Why?
Sir, is this answer correct or not? Then I will explain, sir.
Okay, assuming it is correct, you tell me.
Sir, I put sir z is equal to e to the power it.
Okay.
Computed the dz is
Let me do it here. Okay. Integration over c z square. You had dz. And what you did?
I have put sir z as e to the power it,
E to the power 2it. Then, right?
and sir dz is I times e to the power it dt.
It dt. Okay.
Yes, sir. Then
I times
e to the
minus
power
pi.
3 it dt 1 by 3 e to the power 3 it.
Right? I am writing correct.
Yes, sir.
1 by 3 times.
Minus 1 plus 1. So it will be 0, sir.
Right? This one. What is this one? 0. What is cos pi? 1.
Minus
Cos
1.
cos 3 pi is minus 1.
Hmm.
And minus of minus
This.
1.
Hmm.
This is 0. Okay. Then that is the thing. Both of us are getting same. So it should be 0 then. Okay.
Sir,
Let's.
this is the analytic function sir z square, sir.
Yeah, that also you can use. Z square is
Yeah.
analytic.
So along sir any closed curve, this is integral 0.
That also you can use. Yeah. And otherwise it is the same thing. Yeah. What about this then?
This one. Sir, 0.
Again you got 0?
Sir, I have not computed, sir.
Yeah, no
This is
problem.
sir
No problem. I
very sir.
just, yeah, it must be 0, I think. I also feel. What is this menu? Hey, this quantity only we need to know, right? ZQ minus 7 Z square minus Z plus 6, right?
Hmm.
What is this minus 8? It will be Z equal, oh, when it is 1, it is 0, right? When Z equal to 1. When Z
Hmm.
equal to 1, then it is 2 minus 8 is minus 6 plus, yeah. So you can write like Z cube, Z minus 1. How you did anyway?
Sir, guess.
Sorry?
Sir, I have guessed, sir.
What you did?
Sir, my guess, sir.
Your guess is not like, this is
Sir,
not how
I
it's,
no, I know, sir. But
yes.
sir, it is analytics, sir, inside and along the boundary of the curve. So this must be sir 0.
No, 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 not like that. So wait, 1 6 square. 7 Z square plus 6 Z. What I am making mistake? Okay, okay, Z cube minus Z. Okay, okay, Z cube. Yeah, yeah, here is the mistake. So you do like this, right?
Yes,
What I'm
sir.
doing. So we have to find out the point where whether we can write this as a uh, multiplier factor. We can factorize it.
Yes, sir.
So then
Point
what?
of discontinuity.
Yes. So minus then it will be 2Z square times Z minus 1, right? If to make it like this, so minus 2Z square is there. So minus 5Z Z minus 1, right? So when you have minus plus 5Z, you have to make it minus 6 times Z minus 1, right? This one you can write like this. Why I did, because 1 is a root of this equation, so we can write like this. So then
Yes, sir. Yes, sir.
Z minus 1 times Z cube plus 2Z square minus 5Z minus 6. Again you have to look at what is the root.
Hmm.
Maybe minus 1, maybe let's check. Minus 1 will be
2, sir.
minus
2.
1
2
plus
is sir 2.
2. 2 will
Sir,
be a
2.
root.
Yes, sir.
Minus 1 is also, see, minus 1 also.
Yes,
So
sir.
then Z minus 1, you have to mainly Z minus 1, Z plus 1. You are telling 2 is also root.
Yes, sir.
8, 4, 8. Yeah, yeah, 2 is also so Z minus 2. So then one more root you need to find out mainly. So that will be something like, let's check I or
3.
minus I. I will be minus I
No, sir.
minus,
No, sir. Sir.
yes.
No, sir. No. Okay, sir. I was sir, using the results, sir, for sir, real polynomial. The complex roots are in pair, sir. Sir, we have two real roots, sir, 1 and 2. So,
No, 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 these are not real roots. Real,
yes.
maybe, yeah, 1 and 2 you have, then you have, okay, okay, you will have to have then one more root which is real, right?
But sir, this equation, sir, in complex variable, sir.
Yes,
We
yes.
cannot use that, sir,
Yeah,
result.
it will be 3. I just check it. It is with 3, okay? Then 27, 27, 18,
No, sir. This will not satisfy, sir.
minus 3, no, minus 3, minus 3. Let's say minus 3,
Minus 3.
right? Minus 3, yeah. So Z plus 3. Many you have to find, many that's the factorization you have to find out. So if you factorize it, now what you can see, the points are 1, minus 1, 2, and minus 3.
Minus 3.
But what about modulus of Z? Z is at modulus Z equal to 1 by 4. All these points are not here.
Yes, sir.
It's the outside, not sorry, not here means not inside. They
Yes,
are
sir.
not in mod z less than equal to 4, 1 by 4, right? So what it has to happen, this will be 0 because then it will be analytic, because no point of singularity, so no point problem with the these points which are root of this system, root of this equation.
Sir, if someone do not know, sir, this result, then how will he proceed, sir?
Which one? Then it will be very difficult, right? That's why these type of things are coming. This is why these are very important results, important theorems. These are very important theorems. They have
Yes,
proved it for general any general case, right? So it will be difficult. If it will be like that only. I mean the theorem, the
sir.
how
In
general.
that case, sir, we have to, sir, parameterize the, sir, curve, sir. Mod
Ha,
z is equal to 1
whatever
by
you
4.
do, yeah, whatever you do, that will be very lengthy. That you will see, because z equal to, maybe you put z equal to the power I 1 by 4 u to the power it, right?
1 by 2, sir, e to the power
Uh,
pi by 4i.
pi by 4 I, but modulus of z will be,
So 1 by 2 there, sir. Z is equal to 1 by 2. Yes, sir.
is it? So no, it should be 1 by 4 only, right? Why 1 by 2? Because modulus of z equal to 1 by
Oh,
4.
sorry, sir. 1 by 4. Modulus
Yeah.
Z is already 1 by 4. Yes, sir.
Exactly. So that will be monogeneous. So then you have to put all these things here, and
Yes,
it's going to be nightmare. It's
yes.
gonna be very difficult. I think you try, you
Sir,
will get
first,
maybe.
sir, first I tried to compute in this way, sir.
No,
But
no, no, no,
sir,
no. Don't do.
I
Don't.
realized that this will be, sir, very lengthy.
Yeah, yeah, yeah. Don't do this. So you use this analytic definition. You try to find. See, to know about analyticity, you have to first you have to know about what is this. If you
Yes,
if you see zeros of these functions, zeros of this function is inside this C. C is a curve like this, but inside this, if you have zero of this function,
sir, use
then
Cauchy figure formula.
yeah, that
Then.
in next class we will do that. But if it is
Yes.
not there, then it is
Hmm.
just make it zero, because in this region it is analytic. So the closed integral will be zero.
Yes, sir.
This quantity f is equal to zero on the C if f is analytic on
Inside and along the boundary of the curve.
inside C, and inside C, right? Inside C, not the along
Inside, sir,
the.
along the, sir, inside and along the boundary of the
Inside
curve.
and along, yes, inside and along,
Yes.
that also. Yeah, see, that's the thing. Yeah, yeah, and here you have C minus 1 singularity since the function is analytic inside and on C. Yeah, that's what you said, right? Inside and on C. We can apply Cauchy theorem, which states that contour integral of an analytic function over a closed curve is zero. Thus, we conclude this is equal to zero. This will be your last question for today's class.
Sir, 0.
Why? Tell. The last
Sir,
question only. Finish it up.
0, sir.
Why zero? That's what I'm asking. Why zero?
Sir, because sir, zeros of the sir denominator is are sir 2 to 3.
Oh, you got 2 to 3 as root.
Yes, sir, roots of the denominators, polynomials.
Z cube minus z square minus 8z plus 12 can be written as
Z
2 to
plus
3.
3, Z plus 3, Z plus 2, Z whole square, Z plus 2 का whole square.
Z
Sorry, sir,
plus
Z
3.
minus 2, sir, Z minus 2 का whole square.
Okay. Whatever you get, that will be. I'll just check it whether correct. So 2 and minus 3. Roots are 2 and minus 3.
Yes, sir.
Are they inside z equal to 1? Modulus
No,
z
sir.
equal to less than 1. 2 and minus 3 not in z such that, right?
Yes, sir.
So uh, answer equal to 0. Analytic function on the analytic function on z, the z equal to 1. uh, that's why, so z square minus 1 fz equal to z over this z cube minus z square minus 8z plus 12 is analytic on modulus a plus than equal to 1, and so z over z equal to 1 equal to 0, right? Dz. I think that's all for today's class. We will try to meet in the we will meet in the next Sunday, on next Sunday, again the same time, 3 to 5. So you have any other doubt? So that's all. Here you see answer is this, and then we are
Sir,
done. Yes, tell.
sir, if we have sir roots of sir minus one, sir, third root of unity, sir.
Sorry,
Sir, we have sir, let's say sir, third roots of sir minus one, sir.
root of minus 1. Yes.
Uh, Third, sir, third roots.
Okay,
Third
okay.
root of minus
3
one.
over 2 you were telling like this.
Sir,
Yes.
minus one to the power one by three, sir.
Minus 1 to the power 3 by 2. Yes, yes, yes.
One by three, sir. One by three.
Let me check. Let me write it. Maybe here.
So z is equal to minus one to the power one by three.
Minus. I'm writing. It's not writing minus 1 to the power. Yeah, yeah. This one, right?
Yes, sir.
Yeah.
Sir, then I want to sir find sir the roots of sir minus I to the power one by three.
Minus I to the power 1 by 3. Yes.
Hmm. Sir, is
How to?
there any relation, sir, between both of them?
I mean, you have to find
Like
in the.
like like if I have sir the roots of sir minus one, third root of minus one, sir, then can is it related, sir?
Yeah, they will be related, I think. So we have to find mainly what is minus I to the power 1 by 3. That you have to first of all find. Then you will understand the thing, right? How you do that? Minus I to the power 1 by 3. Even minus 1 to the power I by 3 also it will be same. Yeah, it will be like same type of only, right? How you do that for, let's say, for one of them?
Sir, first we put sir z is equal to sir minus one to the power one by three.
No, 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 no. What you are saying?
Sir, for finding the sir, third root of sir minus one, we first
Yes.
let that z is equal to minus one to the power one by three. Then z is equal to minus one, and then sir minus one can be written as cos pi theta plus I sin pi theta.
Yeah, yeah. Let's say minus 1. Minus 1 will be
Sorry, cos pi plus I sin pi.
plus I sin pi,
This
right?
is equal to z cube, sir.
And this is equal to,
Z cube.
yes, then
Then use sir de Moivre's theorem, sir.
cos
Then then
sin
z
pi.
is equal to cos pi by 3 plus I sin pi by 3.
No, there's some 2k pi plus things are there, right? Where you are, why you are not writing that? If I am sure, then it will be like this, where k is equal to 0, 1, 2. Can you
Hmm.
check it? Can you check it? This is correct.
So this is correct, sir.
So these are three roots, right?
Sir, sir, I have a doubt, sir.
Yes.
Sir, sir, how this gives sir three roots, sir? Because
When
when sir we sir add sir 2k pi, sir, multiple of sir 2 pi, then the point will be again the same point, sir.
no, that is over 3 is also there, right?
Yes, sir.
Right? So it will
After three, sir. Yes, sir. This will complete the rotation. Okay.
again after when it is 3, then it will be equal.
Ah, yes, sir.
So that's why. So k is not there, so you don't need to take all the numbers. It will be just 0, 1, 2.
Then how can we sir proceed for minus I, sir?
Mm-hmm. Sorry.
If we sir know this, sir. Then how can we proceed for minus I to the power 1 by 3 using this?
Zero minus I, minus I times 1. So it will be sine. What is the value of sine in this one? Sine 0, right? Minus I times cos 0.
Why you not write sir cos 0 minus I sine pi by 2?
Okay, 1 minute. That is how you get it. This is minus I 0. So this is will be here minus I 0. Sorry, 0 minus I.
Hmm.
0 minus I. So then what is the angle? Angle
Pi
theta
by
will
minus pi by 2.
minus pi by 2 really. So sine uh,
The cos minus pi by 2
cos exactly minus pi by 2
plus
minus,
I sine minus pi by 2. Minus sine pi by 2, yes.
minus pi by 2, right? So then what you, then exactly you get again same, right? Z will be cos minus pi by
Pi
2
by.
plus 2k pi by 3 plus
Sir
I.
cos minus pi by 2 is 0 na? Why are you writing this?
What is the it does not matter, right? It is 0
Uh,
also, but 2k pi is first one will be 0. I mean sine minus pi by 2 plus 2k pi by
okay,
3.
sir, got it.
So
Got it.
0 1 2, right?
Hmm.
When it is you have 1, then you have cos 2 pi minus pi by 2.
Hmm.
2 pi minus pi by
First
2.
root.
That by 3 also is there.
Yes, sir.
Hmm. So you can evaluate the roots by that way. Okay, what will be the root? So when you have I to the power 1 by 3, you usually get, let me, square root 3 plus minus I by 2. That type of things you get. You just have to check it. I forward plus minus 3, maybe some such things you get.
Okay, sir.
Yeah, but the results are these only. Whatever the value you have, that's all, and that's how you
So,
get.
sir,
Sorry,
roots of sir minus 1 and minus I are not directly related to each other.
root of minus
Third root
one,
of sir, third root of sir minus 1
third root of minus one, and third root of
from minus I.
minus I. So minus I to the power 1 by 3 mainly you are telling, right?
Yes, sir.
Yeah, that I have to see. We have to see. It's not most probably because Z is, you see, it is pi plus 2k pi by 3, and here it is minus pi by 2 plus 2k pi by 3. You can just put the value. You can see the what are the roots you are getting for this, and what are the roots you will be getting for minus 1. For this one, you will be getting 1 omega and omega square, right? If I am correct, that
Hmm.
omega is square root of minus 3 by 2, that type of, plus 1 by 2 I, some such things are there, plus or minus it will be
No,
something like.
sorry, these are sir roots of unity, na sir. Third roots of unity, sir. These are sir third, but that is minus 1, sir.
Okay, 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 okay. Minus 1, sorry, sorry. Not then. Yeah, not then this. So but you can see, right, for minus 1, what are the things we are getting? Minus 1 to the power 1 by 3 you are getting. If you put 0, then it will be cos pi by 3 plus I sin pi by 3, right?
Yes, sir.
Cos pi by 3 is what? Cos pi by 3 is square root
Cos
3.
61 by 2.
Yeah, that type of thing only you will get, right? And then cos 60 is 1 by 2. Yes,
Hmm.
plus I sin 60 is will be
Root
square
3 by
root
2.
3. And when you put k equal to 1, what will happen?
K equal to 1, then 3 pi by 3. Pi minus 1.
Yeah, so what are that?
Minus 1. There, so plus minus there. There will be sir plus minus.
Plus minus will be
mi-
then what?
minus 1 plus minus I root 3 by 2 and 1 minus 1 sorry minus 1 plus minus I root 3 by 2.
I root 3 by.
That is
That's what you are getting for I, right?
yes. No, this
Minus,
is
oh,
for
sorry, minus 1. You are
minus
getting,
1.
this is for minus 1.
Ah, sir.
But you will get it from for minus I. What will happen? When k equal to 0, it is minus 5 by 6.
Yes,
What
sir.
does that minus 5 by 6 mean?
Root 3 plus minus I by 2
Exactly. So, no, plus
and
minus
minus
root 3 minus I by 2. That type of, right? Right?
plus minus root 3.
Minus I by 2. Anyway, this real part will be square root 3, right? Plus minus or something. You just to
Hmm.
evaluate.
Hmm.
But imaginary part will be 1. But here it is the other way, right?
Yes, sir.
So what maxima you can say if after multiplying they equal those type of things maybe. Yeah, maybe there I times that. That one can say maybe.
Hmm. Hmm. I times, sir.
I times that. That only maybe you can say.
But sir, there is a plus minus root 3.
Yeah, you have to find out whether it is plus minus root 3. That's what I'm. Yeah, if plus minus root 3, that's I. That's why I'm multiplying by I, right? If you multiplying by I, then square root 3 times I and plus I square which will be 1 by 2. That is same. So 1 plus minus root 3, I root 3 by 2. See, this is same.
Yes,
You
sir.
understand?
Ah, yes, sir. Got
Yeah.
it, sir.
And minus 1 is there, so that I also it will be coming here. So that's why.
So we
So it
have
might
to
be like
basically
that.
multiply by I, sir.
Yeah. That might be. Otherwise, no other things I can say. Okay, then. Any other
Sir,
question? Yes, please.
yes, sir. Sir, in the sir, previous examples, sir, we were finding the roots of the polynomial in denominator, sir. Sir, is
Yes.
there any quick method to sir know that the roots does not lie within that curve? Sir, because sometimes calculating the roots is sir, very hard, sir, very difficult, sir.
Yeah, I
Because
understand. But the thing is, you have to, if it is a easy kind of like 1, 2, minus 1, 2, 3, plus minus 1, plus minus 2, plus minus 3, or plus minus I. Maximum all these things you can check. Otherwise, it is difficult. That is true. But I don't know whether there are like the, I mean, there
why the
are
Rossi's theorem, sir, we can find, sir.
Roshi theorem.
Yes, sir.
What is
For
Roshi theorem?
sir, for finding roots, sir, we sir form a sir function. Then sir,
Hmm. From a function? I mean, I do not know that what is the
yeah,
theorem.
actually, sir, I forgot that. But sir, next time, sir, we'll discuss.
Yeah. For
Sir,
finding root. Okay.
you can write sir spelling, sir, of the Rossi, sir.
Sorry.
R-O. Sir, have you not heard about Rossi's theorem?
Yeah, means what is that? Rational
Have
number
you
you
heard,
just.
sir? I am asking, sir.
I mean, I'm asking what is the. I mean, this rational root theorem. Are you telling about? We know about rational root theorem. That is something you just
Sir,
whether
this
p by.
is in complex analysis, sir. Rossi's theorem, sir.
Yeah, Ross's theorem, but I forgot the Ross's theorem actually. What is that? That's what I'm asking.
The
This
two
Ross.
complex So two complex valued functions have the same number of zeros inside a closed contour if the absolute value of one function is greater than the absolute value of the other at every point on the
Yes,
contour.
yes, that is okay. But that why that how you find out the roots? Man, that is difficult also. That is again difficult. You have to find another function. I mean, say
Simplest
that
one, sir.
fz less than equal to some gz. All these things were there,
Ah,
right?
yes, sir.
That type of. So, I mean, I felt that is little difficult. I don't know. And because in these all these cases you will see it's between one minus one all this type of root you will see. So whenever you have z, if it is up to z cube, then first put one minus one, two minus two, or plus minus I. All this thing you check. If it is not coming, then you have to go to that. Otherwise it is easy way, right? Otherwise whatever I am telling, that way will be easy, because if you put 1, then you will see that you can write that factor, but you can divide by that factor. If 1 is the root, then z minus 1, but you can divide by z minus 1. So
Yes,
then all the factors you can make it z minus 1, z minus 1 like that, and whatever you have, that will be in the second order. You will be coming second degree polynomial only. You will get right after that z minus 1 times second degree polynomial, and then second degree polynomial is easy to solve, right?
yes, sir.
That,
Yes, sir.
that will be
By
that will be easy. So that
Sridharajan formula, sir.
otherwise Ross's theorem, yeah, that you can use. Yes.
Okay, sir.
Okay.
Thank you, sir.
Yeah, that's all then for today's class. We'll meet in the next Sunday, on the next Sunday. So these are the books and reference. Thank you for your attention. Okay.
Okay, sir. Thank you.
See you. Thank you.